Okay, for today, I'm doing a little bit of a review. The Chapter 14 test is tomorrow. There was some talk of having it today, but obviously we're not having it today, so I got a little bit of review today. So first thought, we started this whole thing with graphing complicated things. I'd like you to try this one. Y equals 2 times tangent of 1/4 pi minus 2, or so 1/4 x, sorry, minus 2 pi. And then we'll just leave it at that. If I had thrown in a +1, what would you have to do to the graph? Just shift it up one, it's no big deal, but that's kind of a pain to have to do. So why don't you just try graphing that one? I'll pause for a second while you give that a shot. See if you have this thing going on the right track here. For tangent in the first place, the parent, I recommend you always start with that. Pi over 2 to negative pi over 2. Raise your hand if you started with the right asymptotes. Okay, good. Then, would you agree that there's two spots on this graph that are kind of important? Right there and right there. Those are 1 and -1. Why are those important? Because we're going to change them both to what? 2 and -2. Why was it 1 in the first place? Because that was pi over 4, and that was 45 degrees, and tangent of 45 is 1. But now that we change this to a 2, we're going to double what we would have had for an answer. So instead of getting a 1, we'll get 1 and then times it by 2, and it's 2. So anyway, if you have 2 and -2 as these two labels, you had a good start. Raise your hand if you have that right so far. Good. Next part is factoring out that 1/4. 1/4 comes out. You have x minus, how do I do this? Well, you can put I don't know what to put here, like a question mark. And then you go 1/4 times x makes 1/4 x. 1/4 times I don't know makes -2 pi. 1/4 times I'm not sure what equals -2 pi. And you solve it. So really then, you have to get rid of this 1/4 by timesing by 4 on both sides. And the answer would be -8 pi, but let's be careful if we use a negative or not. So if I'm going to put I can tell by looking at this negative sitting there that I'm going to need a +8 pi. So I'm going to check that and see if it works. 1/4 times this negative will make it -8 pi. Will make -2 pi. Yay, I did it right. Raise your hand if you had that right. Okay, good. Now, why did I do that? Two things. Number one, this makes me do a renumbering. My period used to be what on tangent? Pi. So period equals 2 pi over b is the old formula. Did you use that one? I hope not, because you needed to change the 2 pi into pi. Why? Because tangent has a different period. Okay, period is pi over b. And our b we figured out was 1/4. Therefore, pi over 1/4. Therefore, this period is, flip and multiply, 4 pi. Does that make sense to you? Okay. Then the old period from here to here used to be 1 pi. Now it's 4 pi. That means that this used to be half a pi, but now it needs to be 2 pi. This needs to be turned into 2 pi. What are we doing to it to make it turn into 2 pi? I don't know if we've caught this yet, but we are multiplying it by 4. That will make it turn into 2 pi. That means this gets multiplied by 4 also. Okay, and this gets multiplied by 4. So my new answers are this becomes 2 pi. This becomes 4 over 4 is 1 pi, which makes sense. It's half of 2 pi, right? Raise your hand if you've got that labeled correctly. Good. And you get the tangent just keeps on going, right? Like there's another one over here, and more asymptotes, and another one over here, and you could keep graphing them forever. Okay? We wouldn't make you graph them forever. But if I ask you to graph one period, the blue one would be one period of tangent. Okay, I'm sorry. I guess I hadn't finished yet. What I had finished was the numbering. So I was just kind of, I want to, in my own defense, I was talking through what we were like going to renumber this to, but I hadn't said that we are, maybe I had, but said that we are completely done. You're right. Now we do need to shift it. Now that we've renumbered this thing to be pi and 2 pi, and this will be negative 2 pi, we had to do that first before we figured out that we have to move it, whatever this is. This is called the phase shift. So we have to move it 8 pi. How far is 8 pi? Well then, this is 2 pi. So if I budge my graph over that far, then from the center of the graph to the center of the graph being here to the center of the graph being here, I would have moved it over 2 pi. I need to move it over 8 pi. Okay, so everything would have to get moved over 8 pi. So it's going to be painful because it's we're going to be way off the screen, but it's going to be asymptotes every 2 pi, right? True or false? True or false? So because you're saying that the period was 2 pi? The period's 4 pi, isn't it? I know this gets confusing, but do you get that these are 4 pi apart? So you remember me writing that right there? Okay, so then this asymptote, which was right here, those asymptotes are going to occur every 4 pi. All right, so I'm going to move this whole graph, though. I'm just going to take everything on this graph, which is basically its squiggly thing and its asymptotes. And I take this whole thing and I'm going to slide it over exactly how far? 8 pi. So now that I know how far 8 pi, or how far 2 pi is, I can keep doing that and move it over the right number of marks. I made this one move over too far to the right because it's going to be hard for me to actually go there. But if I took the center of it and moved it over 2 pi and then moved it over 2 more pi and moved it over 2 more pi, I could figure it out. Yes, sir? Well, it's the same look, absolutely. But, yes, but if I wanted to know where did I move my graph to, it has been moved. The little squiggly thing used to be here, and if I move it over 8 pi, it needs to go way over there. All the squigglies are identical, and all the squigglies are moving together. Yep. So there's like an infinite number of these things that are then moving over. All of them get moved over 8 pi over there, and then all of them would follow. Okay, so that's enough on graphing. Now let's talk about the sinusoidals. Yes? You have to relabel everything. But on the x-axis, all I've asked you for is 2 labels on your graph on the x-axis. So after you'd moved it over, you could like label this in one of the asymptotes, or you could label both asymptotes, or you know what I'm saying? You need 2 things labeled on the x-axis. Okay, so back to besides doing these, we've done a whole bunch of sinusoidals where you like find, you know, I give you the lowest spot, I give you the high spot, and you figure out the sinusoidal for that. We've done plenty of practice on that. Okay, but we just started yesterday where I give you that example of your finger like waving back and forth in front of your face. Okay, and let's say that here's a dock, and I had a chance to go to a place in the Florida Keys where they feed these huge silverfish called tarpon. They feed the tarpon off the dock, and they've been doing it there for so many years that the tarpon know, like at a certain time of day, that they always get fed there, so they just always show up there. And I'm sure now it's generations of fish have been coming there and they get fed, and so like, hey, why not get free food? I'll just come to those dock at a certain time of the day. So it's a smart little attraction for this dock owner, because then he gets a lot of people to come to his place. So anyway, these huge, they're really big. Okay, they make any fish in Lake Minnetonka look small. Seriously, they're just huge fish swimming around looking for their free food. So I'm going to say that this fish, uh, maybe he's mentally ill or something, but he's swimming in a figure-8 notation. Okay, he just keeps swimming that figure-8 notation waiting for his food to come in. All right? And let's say that we do this from the perspective of the dock turns like this. Okay, so you're standing right here. And you get how he's closer to you and then he's further away. And then he's closer to you and then he's further away. And then he's closer to you, and then you get the idea? It's kind of like the finger in your face, like it's closest to you and then it gets its furthest away. And then it gets closer to you and then it gets its furthest away. Yes, sir. 7, 8, 9. Very nice. Okay. Back to, if I have my fish swimming here, and he is making this loop, basically, you can just think of it as, what's the closest he ever got to you? And then what's the furthest he ever got to you? And do you get that it's just going to have a line down the middle, kind of like it would with sinusoidal, like a normal one? All right. So let's say that he is 2 feet away from you at his closest. This is 2 feet. At his farthest away from you, he's at 12 feet away from you. So this is written from your perspective, standing right there on the dock. What would be the equation for the sinusoidal? Now, don't make it negative just because it's going, kind of in my picture, it's going down. From where you're standing, he's getting close to you, and then he's far away. And then he's back close to you, and then he's back far away. Now, I haven't told you enough to write the sinusoidal yet. What else do you need to know? Time. Good. Okay. So I will say that it takes Mr. Fish 20 seconds to swim the full rotation. Not just to swim away from you, but to swim. If he was close to you, by the time 20 seconds elapse, he's gone far away and come back. 20 seconds for a round trip. Good question. Let's say that he starts closest to you. We start this little experiment closest when he's really close to you. Now, I know this can be kind of a mind bender. If I were you, I'd go do something like this and make a little sinusoidal graph that looks more like you're used to. All right, I'll pause for a moment while you see how you have to be able to adjust your thinking. You get the whole sinusoidal idea, but you got to apply it to a new situation. That's what makes this honors pre-calc. Regular pre-calc wouldn't have to do that. I'll pause for a moment. Give that a try. Okay, let me show you what I think this should have been, and you see if you guys ended up agreeing. And I know there was some disputes amongst groups about how to do certain things. Let me show you what I think. Remember how I said it starts close to you? Okay, and so therefore, this distance of 2 feet, it starts close to you. So we're going to say it starts right there at 2 feet away from you. And then it swims away from you. And how long does it take to get all the way back to you again? All right, so then it's going like this. And it gets back to you after 20 seconds. And back to you meaning it's still 2 feet away from you. All right, next, at its furthest from you, it was at how far away from you? 12 feet away from you. Now, it was swimming from 2 feet to 12 feet, and that means its swimming distance was 10 feet, which means the dotted line would run right down the middle of that. If you average 12 and 2, it's 14, and that makes this line 7. Raise your hand if you agreed with me that that line was 7. Now that I got that line, so much stuff falls into place. Then this has to be the amplitude, and therefore y equals 5 cosine. And then the b term's always tricky. You want to have a period formula. Period equals 2 pi over b. By the way, if this had been a tangent graph, would that have been 2 pi? No, it would have been pi. All right, but back to period is 2 pi over b, or b is 2 pi over the period. That's just a rearrangement of the original equation. So what was its period? It's pretty simple. What was its period? The period. How long did it take it to complete a full cycle? 20. 20 was the period. I'm not asking about b right now. I said, what's the period? The period was 20 seconds. Therefore, the b would be 2 pi over 20. I could reduce that to pi over 10. Raise your hand if you either had 2 pi over 20 or pi over 10. Okay, good. So I'm going to throw that into my equation now. 2 pi over 20. I'd say pi over 10 is reduced. That's better. And then I go x minus, did this thing need to get shifted? Yes, it did. Here's why. What I just graphed right here, is that cosine? No, it's not. Okay, that's not cosine, that's sine. Sine, it says starting at its lowest. Okay, to get it to be cosine, the highest point here should have been right there. Okay, so do you get, I could shift it to the left a certain distance, or I could shift it to the right a certain distance? Does it need to be shifted a full period? No, a half a period. And how far is a period? 20, and if it needs to be shifted a half of a period, what's that? 10, and therefore this should be a 10. Now right or left actually would have worked. Let me make sure of that. If I shift it, yep, if I shift it right a half a period, it'll be at its peak, so good. And then the last thing is I gotta go up 7, which is a plus 7 right there. How many of your groups had exactly that as your answer? Okay, good. Yes. Yep. Can you shut that door for us, please? I did, okay, sine, when it's rising, okay, you've got a good point. It's not sine for sure. You're right, hold on. Because sine is in the middle of its swing, but yes, that's a good point. But we were doing cosine either way. So all I was trying to say is this graph is not set up right for cosine, and I did say it was going to be sine, but you're right, it's not sine either. Yes? You could have done this graph with sine, but then it's a much more complicated situation, and I wouldn't recommend it, because I've told you, do use cosine every time. Could you? Absolutely. If you want to risk that when I go through and grade it, that I'm going to be able to figure that out. Okay, so I understand it would be different. And I'm just not going to explain it in terms of sine, because it really will confuse a lot of people. If you want to do it in sine, I'm going to still say, would you please do it in cosine? Okay, so this especially is more complicated maybe than you're even thinking, because it's halfway, it's starting, if it was like a sine, it would be like starting halfway through a sine function, not even at the beginning of sine. So it makes it even more complicated. So anyway, just use cosine. If you want to do sine and you insist, it does say use a sinusoidal. Sine is a sinusoidal, of course, and you could do it that way. All right, just use cosine. It really does make life easier on these problems. All right, last thought is, if I wanted to, I could have said that you put in the number for the x value at its first peak. Do you remember me saying that? Here's its first peak, as in the peak distance from you, and at what time would that have occurred? Do you get how that's the x value of the first peak? That's a really good way of knowing what to put there. Okay, next part. I want you to have a brief overview of the worksheet I'm about to have you look at. Everybody pull up the worksheet on Schoology that looks like this. I'll pause while I pull it at home. So I'm giving a couple of practice problems up on the board here that you could do besides these worksheet problems. Graph this tangent question and then figure out what angles would qualify here. And now the actual worksheet, chapter 14 review problems. Some thoughts on this, first of all. There are a few questions on here, but only a few, that you would have to have a calculator to solve. if you run into those, just tell me what you would have set up. And then you would have typed it in and probably graphed it on your calculator to solve. So I believe, for instance, on number 1, parts B and C, you wouldn't be able to do it without a calculator. But this test we're having tomorrow doesn't allow calculators, but they could say, what equation could you set up for this situation? All right, so all you need is the equation. You don't actually put it in the calculator. So don't anybody have your calculators out for this. It won't help, and it won't help tomorrow either. All right, then as you move through it, I think you'll find some of them really aren't too hard. I did give also the warning that there would be one question very similar to one of these on your test. So if you've gone through all of these and understand how to do them, that'll help you a lot for that. All right, next, when you do get to 6, 7, and 8, it talks about putting this in terms of sine only. Do you remember that cosine squared, you could put that in terms of sine? Do you remember our last test, our most recent test, was proving identities? Do you actually have to know some of these? Yes, I told you there was a few you should memorize. Can you name a few that you should have memorized? Yep, and that's the one that would help for this one. If you know that one, you know this one. So what is sine squared? 1 minus cosine squared. What is cosine squared? 1 minus sine squared. Good. And then it also is going to ask you to factor. It says factorize, which is kind of a weird word, but it actually is an okay word. Basically, it's asking you to factor this. I'll give you a hint. Do you remember substituting in, when things are complicated, substituting in a u? Like 3u squared minus 11u plus 6. Get that factored. And when you're all done factoring that, you substitute back in, instead of u, what do you put back in? Done. All right. So that is not incredibly hard. Just make it easier and factor that, and then swap back out and get your sine function back in there. All right. So there's my hints for this worksheet. And I want you to spend the rest of the hour cranking it out. This is your only homework. The answers are not posted yet, and I will be posting them at the end of the day today.